Part of the question I did this one including we short circuited this capacitance and this capacitance, and in the C parts they are saying repeat the B for the case when capacitor CB is open circuited. So it means now for the AC signal we are not going to have this connected here. This one will be open circuited, but this one still be short circuited, and let's see what's the difference it's going to make. Okay, that's the difference, and they are saying do that and find all the values in the part B. We have to calculate all the values we calculated in the part B and also find the advantage. Okay, let's do that. So this is part B I did in my previous video. You can watch my previous video to see all these things. In this video I'm just going to focus on the part C. Okay, so in the part C, if we draw the T model of this, we draw the T model for part B, that is this one right here. If I start from scratch, then the T model is basically the collector emitter base remains the same, only this BJT will be replaced with, like, we will have emitter resistance and the collector current will be replaced with GMV5 and stuff like that. So let's do that. First we have the vsig right here, vsig, and here this is the rsig, and here we have 10 k ohm resistance, and you look at the circuit right here. This is vsig, this is our rsig, and here we have the 10 k ohm resistance, and that 10 k ohm resistance is connected to these two resistance. These two are, when it's AC signal, this is not going to be 9 voltage anymore, this is going to be connected to the ground. So it's going to form parallel resistance for these two, and these two parallel resistance connected in series with 10k. So this is 20k parallel. You see 20k parallel, and this is open circuited, so it means 20k parallel is connected in series with 10 k ohm resistance. So this one is still right here, 20k parallel with 20k, and if you calculate the equivalent one, is product over sum, 20 times 20 over 20 plus 20, that is 10k ohm resistance. And we go here, the one parallel to this one would be emitter resistance, that is right here, and the top part of the BJT connected with the collector current, that is GMV5, and this one will be grounded on the top, and in the bottom we have a 2k ohm resistor, and V output is right here. So after RE we have the V output, and then we have a 2k ohm resistance connected to the ground, and that is it. And here this is the resistance right here, it will be the input resistance, and the resistance right here is the in RIB, and this RIB is nothing but 1 plus beta, and these two are in series, RE plus 2k. Okay, so that one, if you calculate, RE is readily available to us. It's we did in the part A to find out the RE, and if you don't know what the RE is, that is 14.5 ohm resistance. You plug that one in right here and calculate this value, 2k plus that plus 1 plus beta also provided to us, that is to be 100. You plug it all in and calculate the value, you will end up getting 203.46 k ohm resistance for RIB. Okay. Here we have to find out the input resistance. That's one of the question in part B. In the part B we found out the input resistance and V over V6. We have to do the same thing for the part C as well. So to find out the input resistance here, input resistance is basically this whole resistance right here parallel to this RIB. So let's do that. So if we take input resistance, that is nothing but we have a 10k ohm resistor in series with the 20k parallel 20k, 10k ohm resistor in series with the 20 okay, that is right here, in series with the 20k parallel 20k, which is another 10k. You can simplify and say 10k as well. Okay, so you, in order to illustrate this one better, we can put 20k parallel 20k. Okay, then that whole thing will be parallel with this circuit right here. I mean, not this. This one right here, that's RIB. That's 203.46k, 46k parallel with this. Calculate the equivalent resistance. You will end up getting 18.21 kilo ohm resistance. And if you notice the difference between the one we have, if you notice the difference between, we calculate the R into B, this one when it's connected with a wire. Okay, in the part B we don't have open circuit for it, we connected with a wire. So for that one we got R into B, this one 248 kilo ohm, but if you compare that one to this is 18.21 kilo ohm. This is much less than what we got for the bootstrapping. So we can say which is much lower than the value obtained with bootstrap. Okay, so this is one of the question, like we have to find R in. The next one is we have to find out what is VO over vsig. So let's do that one here. We have to find out VO over vsig. We can also say VO over vsig is equal to V output over, if you watch my previous one, you can also say this one is VB over vsig times VO over VB. Here what we did is we multiply top and bottom by VB. You can do that, since both of them cancel, you can just do that, because by doing that you can get a voltage divider. Voltage divider is nothing but this R in over R sig plus R in. Okay, and others remain the same, VO over VB. But here we know the R in, we know the R sig, we don't know the VO, and we don't know the VB. What do we calculate? We just calculate the R in only, so we need to know both of these in order to solve this problem. So let's see how we can find those things. So first, if I start with VO, VO is right here. This is like by using Thevenin equivalent, you can put this 2k over RE multiply by the V5. V5 is right here. Okay, 2k over RE multiplied by V5 give you VO. Okay, so RE is already known, that is the 14.5, that is from part A, 14.5 ohm resistor. You plug that one in here, divide 2k divided by 14 point, this value, that is 14.5 multiply by V5, you will end up getting, let's actually put that one value as well, 2k over 14.5 times V5, we will end up getting 138 V5. And then VB is nothing but, if you look at the circuit right here, VB is the voltage right here. Okay, this voltage minus V5 minus VO should be equal to 0. Therefore, we can say VB is equal to V5 plus VO. And VO we calculated to be 138 V5. So 138 V5 plus 1 V5, that's 139 V5. Okay, now we have everything that we need for this expression. Now we can find out the V over vsig, which is equal to R in. R in we calculated to be 18.21K. Plug that one in. And R sig is the value right here, that is 10K, that is in the diagram. 10K. So this one become 10K plus 18.21K multiply by VO, that is 138 V5, divided by VB, that is 139 V5. And if you calculate this value, you will end up getting 0.64 voltage per voltage. This is our gain, but we had to find out the gain in decibel. To calculate the gain in decibel, you use this equation. Voltage gain in decibel in dB is 20 log 10, whatever the value of VO over vsig. In this case, that is 20 log 10. The value we calculated is 0.64. And if you calculate this one, you will end up getting negative 3.87 decibel. Okay, and that's our final answer. And if you compare this one with part B, in the part B we got 0.418 decibel, and here we are getting negative 3.87 decibel. So this one is like much lower than compared to the value we got in bootstrapping. So we can say that much lower, than the value obtained by bootstrapping. This is due to lower Rin. This is due Rin. Bootstrapping raises the component of input resistance due to the base biasing network. Okay, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.